Hello all and welcome back to the Basics.Academy channel. So today we are going to solve the problem of max consecutive ones. Let us see what the problem statement is. The problem statement is, it says, given, let me zoom it up. Given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. If you can flip at most k zeros, okay? So here, this is our nums array. We are given k equal to 2. Explanation 1, 1, 1, then followed by 2 zeros. Then again we have bolded numbers where flipped from 0 to 1. The longest subarray is underlined. Okay. Given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. The constraints include nums.length is greater than equal to 1 and less than equal to 10 raised to 5. Nums of I is either 0 or 1. Then k is greater than equal to 0 and less than equal to nums.length. K can be 0 as well. Okay, now let us copy this question and go to our AI interviewer. This is the problem statement. Approach. It is a sliding window problem. The though being we have to return the maximum number of continuous consecutive ones. The clue being we have to return the maximum number of consecutive ones. Consecutive also implies adjacent. Constraints are k is greater than equal to 0 and less than equal to nums dot length. And nums of I is either 0 or 1. Here the main task is to find the longest occurrence of consecutive ones. This is a variable maximum sliding window problem because depending on either because is simple words, the window will shrink and also expand. And edge case would be if k is equal to 0, then return. Question says in the array if you can flip at most k zeros. If k is 0, there is no need to flip any zeros. So output in that case will be, let us say here k is equal to 0. So what will be the output? Since we have to return the maximum number of consecutive ones in the array. Yeah, if k is 0, in that case, all you have to do is just calculate the maximum number of consecutive ones and return that. So if k would have been 0, then the output would have been 4. Got it. Then return in the given array the longest occurrence of ones. Now let us see what does our AI interviewer thinks about our approach. Okay, so let's skip the slow warm-up and go straight into testing your understanding. Sounds great. Setting default voice.
Welcome to LeetCode 1004, Max Consecutive Ones 3. You shared a solid approach overview. So let's jump straight in.
Okay.
You mentioned this is a variable sliding window problem. Tell me what exactly makes the window expand and what makes it shrink.
Consider this example. Here, a first window. Here, the first window has 3 consecutive ones, right? However, after this, if we flip 2 consecutive zeros with 1, okay, after this, if we flip 2 consecutive zeros with 1, if we flip 2 consecutive zeros with 1, then the longest occurrence of 1 becomes 5. Thus, window size is 5. Then we see starting from index 0, 1, 2, 0, 1, 2, 3, 4. So starting from index 4, when we flip 2 zeros with 1, then the longest window becomes 6. Hence, I think this is a variable sliding window problem. Okay, but I want to push.
We'll walk through the example, but I want to push on the mechanics of the window itself. You described the result, the window ends up size 5, then size 6. But what is the condition that tells your code shrink the window now?
Okay. Shrink the window now. But what is the condition that tells your code shrink the window now? Shouldn't it be expand the window? Shouldn't oh Jeffy about it. Oh got it. That condition would be, let me just go to VS Code. So here, if I start from 1, right, the left will start from 1, then this one, then this one. After that, what we do is we flip these 2 zeros to 1. When we flip these 2 zeros to 1, when we flip these 2 zeros to 1, After flipping these two zeros to 1, the max consecutive ones becomes 5. Then after this, okay, so if the left element going out is already 1, and if the right element coming in is 1, is 0, and k is initially 1, then consecutive ones will increase by 1. Then after that, if the left element going out is already 1 and the right element coming in is 0, and now k is equal to 2, in that case it will increase the length of max consecutive ones. So now we have already increased or flipped 2 zeros. Then after that what we do, we encounter one more 0. After that we encounter one more 0. Now in this case, right, so first when this 0 came in, when first 0 came in, 1 went out. When second 0 comes in, again 1 went out. When I say went out of the window, went out of the window. Now when third 0 comes in, right, that time also again 1 went out. But here we cannot flip a 0 because k has reached, or because the max flipping of zeros has been reached. So in this case what happens? Because the max flipping of zeros has been reached, we update max consecutive ones equal to 5. Then if we start from this incoming 0, okay, now the element after this, the element going out but here we cannot flip the 0 because the max flipping of zeros has been reached, which is at this point the max flipping of zeros has been reached, right? The max flipping of zeros has been reached. Hence we update max consecutive ones equal to 5. Then this the element goes out is 0 and the element coming in since we are finding max consecutive ones, so if nums of I is 1, okay, good, 1 good, 1 gold left, so we will have books left maybe 1 1 1. How do we fix the window size, right? Since the window size is not fixed, so sure we update max consecutive ones to 5 for 5, right? So can we see 3, 4, 5? Tell you when now. I think I think I am getting confused around the window length. What besides the window length? My approach is start from left equal to 0, k is equal to 2 for p. Start from left equal to 2 and k is equal to 2. Thus, move window in size of 2. Is this correct or am I missing out something? Let me redirect you.
That's a common misconception. Let me redirect you. The window size is not fixed at KK is not the window size, it's a budget you carry inside the window.
Okay.
Think of it this way, your window can contain any number of ones, none zeros, as long as the count of zeros inside the window never exceeds k. That's your only constraint.
Okay.
So with that in mind, when does the window shrink?
Think of it this way, your window can contain any number of ones and zeros as long as the count of zeros inside the window never exceeds k. Okay. Your window can contain any number of ones and zeros as long as the count of zeros inside the window never exceeds k. Okay, so we start with 0, left equal to 0, what is 1? You left, again 1, move left, again 1, move left, it is 0 and key is 2, so flip it. Okay, 1, again move left, now key is, it is 0 and key is 2, so this is the second flip. Okay, now left is at 0, 1, 0, 1, 2, 3, 4. Left is here, then when we move from here, again we encounter 0. When we move from here, again we encounter a 0. So that marks the end of the current window. That marks the end of the current window. Right? That marks the end of the current window. Then since and wherever left has reached, so that becomes the max consecutive ones. After that, since we are encountering a 0, okay, so we keep on traversing as long as a number of times zeros flipped is less than equal to k. Less than equal to k when it reaches k and the next element is again 0. In that case, record the current max consecutive ones. And then now left is equal to next element index which is 0. So the next window calculation will start from the current left. Okay, we will check. Start from the current left. Again, we will check. Again, we will go on increasing the window size as long as the number of times flipping zeros is less than equal to k. Then we take the max of current max consecutive ones with the new max consecutive ones and return that result. Okay, you got the core intuition.
That's much closer. You've got the core intuition right. But I want to challenge one thing. You said left moves to the next element, which is 0. That's not quite right and it could cause a bug.
Consider this small example.
Consider this small example 1 0 1 0 1 with k equals 1. When you've used your 1 flip and hit a second 0, where exactly should left move to and why?
Okay, so k is 1. We start with left equal to 0. We start with left. Consider this small example. We'll start with left is equal to 0. Then the next element is again 1 0, so we can flip it. So that becomes 1. The next element is again 1. Then the next element is 0. But k, we have used up all k. So here max consecutive ones is 3. The current max consecutive ones is 3. Okay. Then got it. I think we will start with left hand line equal to 0 and keep on moving right. And when we have used up all clipping of zeros to less than equal to k, then we move left to the right pointer and then keep on going the right curve. Move left to the.
You're getting warmer, but move left to the right pointer is still not precise enough and it would skip valid elements.
Let me make it concrete. Walk through the step by step.
Now we must shrink. Left is at index 0, which holds a1. If we move left forward by 1, do we recover any flip budget?
Okay, let me make it concrete. Walk through this step by step. K is 1, left and right. R is 0, it's a 1. Flips used 0, window of 1, size word. R is 0. Okay, when R is 1, it's a 0. Flips used 1. Window becomes 1 comma 0, size 2. Now R of 2 is again 0. It's a 1. Flip used 1, window 101, size equal to 3. R3, R equal to 3, it's a 0. No. When R is equal to 0, it's a 1. Right? So window is 1, size is 1. When R equal to 1, it's a 0. So we have used 1 flip. Now window becomes 1 1, not 1 0. Size equal to 2. When R is 2, it's a 1. 0, 1, 2. It's a 1. So flips used 1, window becomes 1, 1, 1. So size equal to 3. R equal to 3. It's a 0. Flips used 2 exceeds k. Now we must shrink left. Left is at index 0, which holds a 1. If we move left by 1, do we recover any flip budget? No. Yeah, by R equal to 0, it's a 1, flips used 0, window 1. R equal to 1, it's a 0, flips used 1, window. Okay, R equal to 2, 1, flips used 1, window 1, 0, 1. Size is 3, R equal to 3, it's a 0, flips used 2 exceeds k. So 1, 0, 1, right? Now what happens? Now we must shrink left is at index 0, right? So R is moved here and left is at index 0, R is moved here. Now we must shrink left is at index 0, which holds a 1. If we move left by 1, do we recover any flip budget? If we move left by 1, do we recover any flip budget? If we move no. After the above states, left will be here and right will be here. What do we be by? We recover any flip budget. A recovering flip budget means
Good question. Recover in flip budget means when you move left forward and kick an element out of the window, if that element was a 0, your flips used count goes down by 1. If it was a 1, nothing changes. So the shrink rule is move left forward one step at a time until flips used is back to k or below. Now back to your example. At the moment flicks exceed k, left is at index 0 which holds a 1. You move left to index 1, what does left now point to? And did flicks used change?
left points to 0. So the shrink rule is move left forward one step at a time until flips used is back to k or below. Yes, at a time until flips used is back to k or below. Left points to 0. Now back to your example, at the moment flips exceed k, left is at index 0, which holds a 1. You move left to index 1. What does left now point to and did flips used change? Left points to 0 and yes, flips used will change as per the shrink cover.
Exactly right. Left now points to the 0 at index 1. And since we kicked out a 0, flips used goes from 2 back down to 1 which equals k. So we stop shrinking. So the window is now from index 1 to index 3, and right continues moving forward. Now where do you record the max window size? Is it only when you shrink or at every single step?
Oh, so the window is now 0 on 0. It's 0 1 0. So the window is now 0 1 0 from index 1 to index 3, and right continues moving forward. Now where do you record the max window size? Is it only when you shrink or at every step? Only when you shrink. Okay.
Not quite. Think about this carefully. What if the array is 1, 1, 1, 1 and k equals to, you never shrink at all? Would you ever record the max?
Got it.
The max window size should be recorded at every step when right expands, specifically when the window is valid. That way you never miss the case where you reach the end without ever needing to shrink. So the structure is expand right if valid, record max if invalid, shrink left until valid again. Does that make sense?
Yes, that makes sense. But why are you giving answers?
You're right, my bad. Let me get back into interviewer mode. So in your own words, what is the window size at any given point and how you calculate it using left and right?
At any given point, the window size is. So in your own words, what is the window size at any given point and how do you calculate it using left and right? At any given point, the window size is valid as long as flipped count is less than equal to k. As soon as the flip count comes greater than k, then you move left by 1 and keep on shrinking the window as long as a flip count doesn't becomes equal to 0. How do you calculate the window size?
Good, but I asked something more specific. How do you calculate the window size as a number using left and right?
Will be right minus left.
Choose but off by 1. Try it on a concrete example.
The right minus left plus 1.
If left equals 0 and right equals 0, that's a window containing one element. What does right minus left give you, and what should it give you?
It should be right minus left plus 1.
Exactly right minus left plus 1, that's your window size.
What's the
Now you have everything you need. What's the function signature for this problem?
Let me get that from LeetCode.
Good. Now go ahead and code it up.
Dot add left. At any given point, the window size is valid as long as the flipped count is less than equal to k. As soon as the flip count becomes greater than k, then we move left by 1 and keep on shrinking the window as long as the flip count equal to 0. Let lift count equal to 0. Let max consecutive ones equal to 0. Then we use a for loop for let I equal to 0, I less than nums dot length, I plus plus. Should we define left and right inside? No need. Let left equal to 0 and let right equal to 0. So the condition is the window size is valid as long as window size is valid as long as flipped count is less than equal to k. See here, y flipped count is less than equal to k. We will keep on moving right. As soon as the flip count greater than k, then we move left by 1 and keep on shrinking the window as long as the flipped count is equal to 0. While flipped count is less than equal to k, right plus plus and width count plus plus. As soon as window size comes greater than no, as soon as flipped count becomes greater than k, then shrink the window until flipped count is equal to 0. So y not flipped count, then here y load flipped count so while flipped count is greater than 0, do this, shrink the window signs, that is left plus plus and then flipped count minus minus. Once this is done, so max consecutive ones is equal to math dot max of max consecutive ones comma left comma right minus left plus 1, and at last we return the max consecutive ones. Okay, so let us consider this example 111. K is equal to 2. Flipped count is initially 0. flipped count is initially 0. Then we start from I equal to 0 and I less than nums dot length. But should it be less than nums dot length? Or should it be less than if I goes to say nums dot length? I think here this is rule. We will have to include k will come here. Which we will have to ensure that I plus k minus 1 is less than equal to nums dot length minus 1. So I plus k should be less than equal to nums dot length. That will be the condition here. K should be less than equal to nums dot length. Let us dry run this. So initially we have nums equal to 1. I starting from 0. Left and right both are at 0. Flipped count is 0. Now 0 is less than 2. So we increment right and flipped count is 1. Then again now flipped count is 1 less than equal to k. So now flipped count is 1. 1 is less than 2. Then we do right plus plus. So right was here. After first iteration right moved here. After second iteration right is here. And flipped count is now 2. Then we do flipped count plus plus. And here is base call. Let us try run this. This is our array, right? So initially flipped count is 0, max consecutive ones is 0, left is 0 and right is 0. Now when chi is equal to 0, while flipped count is less than equal to k is equal to 2. So flip count will go from 0, 1, 2. Meanwhile, right will go from, after you put say 3 times incrementing, 1. After first increment right will be here, after second here, after third here. So right will be at 0, 1, 2, 3. Equal to nums of 3, which is equal to 0. And then after this we check while then max consecutive ones will be calculated here. This is the correct location. After first while loop, then we set max consecutive ones equal to max of 0 comma left right is at index 3 minus 0 plus 0 plus 1. So max consecutive ones is equal to 4. And then we have while flipped count is greater than 0. So we do left plus plus. Left is equal to flipped count is at 2. So left will go from, it is at 0. So first incrementation left will be here. Then flipped count will be 1. Right? Then second increment left will be here. And then flip count will be 0. So left will be at nums of 2 which is equal to 1, and then flipped count will be equal to 0. So now what happens? We are incrementing. I don't think we need a for loop over here because nowhere we are using I. Yes, the for loop is redundant. There's no need for for loop. We just remove this. This no need for the for loop. Will be have us 2 while loops. But no, we must need a for loop because so now after this what we are seeing is I is equal to 1, and then for the next iteration, since you're not incrementing I, so I plus k will never be less than equal to nums dot length. This will go in an infinite loop. Yeah, we are incrementing I here. Okay, so when I becomes 1, so I plus k is 3. 3 is less than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Less 3 is less than 11. Again, now left is at index 2. Say 0, 1, 2, left is here and right is here. Right? And what we do, while flipped count is less than equal to k, yes. So first right will move here, second right will move here, and third right will move here and stop. Now in this case, left is here and right is here. So right is at index 0, 1, 2, 3, 4, 5, 6, 7, and left is at index 0, 1, 2, 3. So 7 minus 2 will be 4. So this will not be taken into consideration. Then we are going to shrink the window as long as flipped count is greater than 0. So upon first shrinking, left will move here. Upon second shrinking, left will move here. So left will stop here. Now from here, again, what we will do, we will, while flipped count is less than equal to k, while flipped count is less than equal to k, right plus plus, flipped count plus plus. Right is here, right? Right was at index 0, 1, 2, 3, 4, 5, 6, 7. Right is here. In this case, right is here. So we are going to, if flipped count is less than equal to k, right will move here, here, and then at last here. So ideally, it should go from right should be less than equal to, or right should be less than nums dot length. So while right is less than nums dot length, do this. I don't think this is the diagram. Let me just get this to plot. I think I have missed out something. Okay, come on AI, point out the errors.
I can see some significant issues here. Let me ask you about them one at a time. Look at your inner while loop. You are incrementing flip count every time right moves, regardless of what the element is. Should you be incrementing flip count for every element or only for a specific type?
Only for a specific type when lungs of right is equal to 0. And not nums of right, which means nums of right is equal to 0. Left moves to sync.
Correct. Now look at your street loop. You are decrementing flip count every time. Left moves too. Same problem. When should you actually decrement flip count while shrinking?
In my shrinking, my flip count is greater than 0. Is we have to look at the example. While flip count is greater than 0 and nums of left see boolean should you actually decrement flip count by check. If now look at your shrink loop, you're decrementing flip count every time left goes to. Same problem. When should you actually decrement flip count while shrinking? When nums now left is equal to 1. When left goes forward and keeps
Almost, but think again. When left moves forward and kicks an element out, which element type actually frees up fit budget?
got it. It will be nums of left equals 0.
Exactly. Now there's one more structural problem. Look at your shrink condition. You are shrinking while flip count is greater than 0. But should you really shrink all the way down to 0 flips?
With this, here we will nums of left equal to 0. Again, same condition. Now this is one more structural problem. Look at your shrink condition. You are shrinking while flip count is better than 0. But should you really shrink all the way down to 0 friends? To be down to 0 fits. No.
Is that
Low, shrink.
you're on the right track, but that condition is still not right. What is the actual condition that tells you to keep shrinking? You shrink because flip count exceeded k, so you stop shrinking when flip count is back to what?
You shrink because flip count exceeded k. So you stop shrinking when flip count is back to. Stop shrinking when flip count is back to k.
Exactly. So the shrink condition should be while flip count is greater than k. Now there's one more big structural issue. Your outer loop uses I but never uses I anywhere inside. What should actually be driving the outer loop?
So the shrink condition should be while flip count is greater than k. K, my flip count is greater than k and not nums of left. What should be driving the loop? Your outer loop uses high but never uses high anywhere inside. What should actually be driving the outer loop? Right.
Exactly. So ditch the inner while loops entirely. The outer loop should be a single for loop where right moves one step at a time. Try rewriting the whole thing with that structure.
So ditch the inner while loop entirely. The outer loop should be a single for loop where right moves one step at a time. Let me remove this from here. So let right equal to 0, then we do right plus plus. Window size is valid as long as flip count is plus any part, okay, and nums of right is equal to 0. Then it is saying we to ditch the inner while loop. So ditch the inner while loop entirely. The outer loop should the outer loop should be a single for loop where like moves one step at a time. If I remove this from here, then for right equal to 0, we will check if flipped count if we'll run this only once. If I touch the inner while loop, how when flipped count we keep on increasing as long as it does not reach k. We will need inner while loops to apart from the floater for loop.
Good pushback, but think about it differently.
In every iteration cycle.
The outer for loop already moves right one step at a time on every iteration. So inside the loop body, right is already at the new position. What do you need to do with that new element before checking if the window is valid?
Okay, the outer for loop already moves right one step at a time on every iteration. So inside the loop body, right is already at the new position. What do you need to do with that new element before checking if the window is valid? If flip count less than equal to k, then go to continue. Here, this
You're getting closer, but there are still two bugs. Let me ask about them one at a time. Inside the if block you are doing right plus plus manually, but the for loop already increments right for you. What happens to right if you increment it twice?
My bad. Removed that right plus plus from within the if condition.
Good. Now look at your shrink condition. You're only shrinking when nums left is a 0. But what if the elements at left are all ones? Will you ever escape the invalid state?
Look at your shrink condition. While flipped count is greater than k and not nums of left, you are only shrinking when nums of left is 0. But what if the elements at left are all ones? Will you ever escape the invalid state? No. So the shrink loop
Exactly. So the shrink loop should always move left forward, but only decrement flipped out under what condition?
lead should always move left forward. But only decrement flipped count under what condition? Under a condition as long as a count is greater than k.
Almost, but you are conflating two separate things. Left should always move forward in the shrink loop, but flipped count should only decrement when the element being kicked out is what value?
Okay. When LeetCode. But you are conflating two separate things. Left should always move forward in the shrink loop, but flip count should only decrement. But it. If nums of left only then flipped count minus.
Very close, but there's a subtle off by one bug. You're incrementing left first, then checking nums left. But which element are you actually kicking out of the window, the one at the old left position or the new one?
That fix that as well. Vote left plus plus after the if condition.
Good. Now put the whole solution together and share it. There's still a logic, but I want you to catch yourself. Trace through this example. Nums is all ones with k equals 2. Walk through each iteration and tell me what max consecutive ones is at the end.
So k is equal to 2. K right starts from 0. Right is less than nums dot length right plus plus. Then flipped count. Decision 0 is less than 2. And nums of right. K not nums of right. Okay, so in this case, flipped count is not increased. Flipped count stays at 0. And then max consecutive ones is 1. Right is at index 1, so 1 minus. So initially it is 1. Then right goes to 1. In that case also we'll come here right goes to 1, 0, 1, 1 minus 1, 1 minus 0 plus 1, so right is not 2. Then when right goes to 0, 1, 2, so that time left is still at 0. So z2 minus 0, 0 plus 1, 3, right? 3 before. Okay.
How does it become full? Walk me through the iterations. When exactly does max consecutiveness get updated?
So the array is nums 1, 1, 1, 1. Initially, you count is 0, left is 0, add max consequent to ones is equal to 0. So for the first iteration, when right is equal to 0, it will check if flipped count, that is 0 is less than or equal to k, true, and not nums of right. If nums of right is 1, it will not go inside the while loop. This condition will be evaluated. So here this will become this is 0, where it is 0, left is 0. So the max of 0 and minus 1 is 0. When the right equals 1, that time max consecutive ones become still 0, then right is 1, left is 0 plus 1. So this becomes 1 minus 0 is 1 plus 1, 2. When right equals to that time, it becomes max positive ones here as CO. Here it is 2 from the previous iteration. Right is now 2. So 2 minus 0 is 2 plus 1, 3. Comes 3. And when right equals 3, that time this is 3. Right is 3, electricity is 0. Then plus 1, 4. Okay, right is less than nums dot length, right? So right can never become 3. Okay. So the bug is right minus left plus 1. But right will never be 3 because we are saying right will go from 0 to less than nums dot length. But okay, yes, it can be because nums dot length is 4. So right is 3. Okay. Here is the what?
Good trace, but look at right equals 0 carefully. Nums at 0 is 1, so the if condition is false. So where does execution go?
Right equal to 0, nums of 0 is 1, so the if condition is false. So where does execution go? The if condition is false. The execution goes to the next line after if, which is your max.
Exactly, and that's the bug. Your max one's update only runs when the element is A1, but it should run on every single iteration. What's the fix?
Okay. Exactly, and that's the one. Your max consecutive ones update is sitting in the wrong place. It only runs when the element is a 1. Okay. It should be moved to the first line of the for loop.
Almost, but if it's the first line, you haven't processed the new element yet. Should it be at the top or at the bottom?
If we keep it at the bottom, the left will go in place and the batteries will.
Let me push back on that. By the time you reach the bottom of the loop, the shrink while has already restored the window to valid. So why would left be wrong at that point?
By the time you reach the bottom of the rule, the shrink while has already restored flipped count less than equal to k. So the window is valid at that point. Why would left be wrong? Okay. In case of all ones, you got it. It should be at the bottom.
Good. Also, you can remove the continue statement now since the max update happens at the bottom regardless. Now put the final solution together and share it. Good structure, but that if condition on the expand step is still wrong. Do you actually need the flipped count less than or equal to k check there? The shrink loop right below already handles exceeding k.
But that if condition on the expand step is still wrong, choosing the flip count is a simple what it.
That's it. That's the correct solution. Let me do a full review.
Okay.
Directness is solid. Time complexity is O of n, space is O of 1. Your variable names are keen and readable.
Let me run this now.
Score 6.5 out of 10. You identified the right pattern early, but the implementation needed significant coaching to get right. One concrete improvement before writing any code: dry run your algorithm on a small example by hand. Every bug today would have been caught in a 2-minute dry run. Ready for the post-mortem? You spotted the pattern correctly, that's the most important thing. But next time write the skeleton first, expand, check constraint, shrink, record hyphen slash then fill in the details. Don't jump straight to full code.
Okay. So heads up, just to inform you all, DSA, it seems yesterday I was able to solve the sliding window problem within an hour. But today, this took me around 1.5 hours. So it is like mathematics. The next step is dependent on the previous step. But I'm here to persist, get things done, and be better at DSA problem solving. No matter what the hurdles are, just keep doing it one day at a time. If it is hard, no one is doing it. That means more for you. I think this was said by Chris Williamson. So yes, stick to it one day at a time, and we will get there. So here we have ran the code. So the test cases are executing successfully. Now let me submit this code. Submitting this. So here we are at 3 millisecond runtime, and this is our solution. Let's just walk through it one more time. So what we have done is we are using left and right. When the nums of right is 0, right? Only in that case we increment the flip count, and when the flip count becomes greater than k, in that case we check that the nums of left is again a 0. Only in that case we decrement the flip count and keep on incrementing the left pointer. And at last we do max consecutive ones, wherein we use math.max and get the consecutive ones by using right minus left plus 1, and at last return the answer. So thank you all for joining today. I hope you would have learned something valuable today. If yes, please do like, share and subscribe. You would have loved the struggle. You would have loved the struggle as well. But at the end, when you get the result, when you understand the problem, when you learn the concept, it is satisfying. So thank you all. See you in the next video.